Alrighty. I just got done with the sound check, which is probably not the best time to do after I finished recording like a 15-minute video, but yeah, the sound worked great. Next thing we're going to talk about is the triangle midsegment. So this one is another one of those detailed theorems that it's hyper specific, but it's also pretty useful if you know when and how to use it. So which is kind of what we're here to do. So the triangle midsegment theorem is basically if you have, and again, I'm going to use my drawing because my drawing makes the most sense to me. If there's an explanation that you can find that helps with you, then good on you. So if you have a midpoint, so if you have a midpoint between A and B, I'm going to call it D, and then you have a midpoint between A and C, I'm going to call it E. And this is just a generic triangle. It works with every single triangle. So these two sides are equal, and these two sides are equal. May not be, AD may not be equal to AE. It doesn't matter. The important thing is that these are midpoints here. Not only will DE and BC as lines be parallel to one another, but DE will also be half the length of BC. And so that's that's the triangle mid-segment theorem, and with all the different proportionalities and different, so there's that. I guess we're ready for some problems. I suppose. We'll see if we're ready for some problems. Hopefully we are. Let's see. I'm trying to get this all on camera here. Anyway, let's see. Find CD if CD is the midsegment of. Hang on. Oops, wrong direction. There we go. All right. Find CD if CD is the midsegment of XYZ. All right. Well, based on the identity that we have, CD is the midsegment of triangle XYZ. Then that means that it's equal to half of the opposite side. So these two are going to be parallel, and CD equals 1/2 of XZ, which is 1/2 of 16. I mean, I keep telling everybody to show their work. I guess this is the best I can do, which is 8. So, all right, any questions? No, I'm just. Then we'll move on to another problem. I got to check to see if. Yeah, this has two sides. All right, that makes it a little bit more sense. All right, if I have to find AC if TS is its midsegment. I'm not sure if it shows up really well on the camera, but TS is going to be the midsegment of this triangle. And it says that it's length of 4. Well, if this is length 4 and it's the midsegment, then AC is going to be twice that. So, all right, we're we're moving forward. We're moving on. Hopefully this will keep you all occupied. Hopefully part of this will keep you all occupied for the term. Otherwise, I have to come up with a different assessment preparation. All right, so find X if QR is the midsegment of WXY. Okay, well, this one's a little bit more respectable. This one's a little bit more challenging. Let's see what I've got here. So anyway, what I know is if this is the midsegment and splits it up here, I know that whatever this is, it is 1/2 of this. So what I'm going to do is X plus 9 equals 2 times 2X minus 3. Because this side here, X plus 9, whatever this is, this side here is 1/2 of it. So in order to make this equal to this, I have to multiply it by 2. So that gives me X plus 9 equals 4X minus 6. I'm going to move all my X's around, so that gives me 5X equals, so that gives me 5X equals 15. So X equals 3. So that gives me X equals 3, which is good, except that I'm not finding, it's like, wait a minute. Yeah, let's see, find X if you are, oh, well, I guess I am. All right, I'm done. I'm just so used to finding X and then finding out that I'm supposed to actually use X to find something else. I'm like, oh, well, in that case, I'll just keep moving forward with the problem. All right. We are still moving on with the midsection here. So find X if J is the midsegment of TUV. All right. If ij, all right. I don't really know why they're giving us this x plus 6 because it doesn't matter. X minus 3 is 1/2 of x plus 6. So x plus 6, I think it's just one of those things they're putting it in to throw you off because, like I said, it doesn't really matter. X plus 6 equals 2 times x minus 3. So x plus 6 equals 2x minus 6. So that I'm going to move some x's around, so that gives me x. So 2x minus x is x, and then I'm going to add 6 to both sides, that gives me 12, so 12 equals x. Yeah. Okay. I mean, there it is. All right. Like I said, this was confusing, but it's ultimately meaningless. Well, it's not meaningless per se, but I mean, if we know that if this line here is the midsegment, then we know that this line here is half of this line. And that's all we really need to know in order to solve it. This is just extra information that I don't think we need to use at all. So, yeah, all right, moving forward. Okay, find, oh, here we go. Get it on the camera here. Find kj if kj is the midsegment of ABC. So, I mean, if kj is the midsegment and AC is the side opposite it, then kj is going to be 1/2 of AC. So, I'm starting to think there isn't really that much to this theorem, but we'll give it a try. There's one more problem. Maybe it'll be complex. Maybe it'll be difficult. So. All right, find x if BC is the midsegment of triangle RSG. All right, here we go. Okay, getting a little bit more complex with the algebra. Still not too difficult, relatively speaking, but we'll go ahead with this one. All right, so x plus 29 equals 2 times x plus 19. Because again, if this is the midsegment, then this is going to be 1/2 of whatever this one is. All right, so x plus 29 equals 2x plus 38. I'm going to move some x's around, so that's going to give me, well, isn't this weird? So I want to make sure I get this right. So x plus 29, that's the side that's double, 2 times x plus 19. 2 times 19 is 38, 2 times x is x. All right. Well, I'm going to move my x over, so that's going to give me, I can subtract x from both sides, so that means that I've got x on this side. Now I'm going to subtract 38 from both sides. It's going to give me a negative number, but 29 minus 38 equals -9. All right. I mean, the thing is that, let's see, x equals -9. So if x equals -9, that makes it 10. That makes this 20. Oh, all right. Well, I guess that works out then. So yeah, x equals -9. X -9 plus 19 is 10. -9 plus 20 plus 29 is 20. That makes this one length 10. This one length 20. This is 1/2 of this. Oh, well, all right then. Let's well, we shall carry on then. Let's say this is probably going to be a one and done video. I won't have to splice 2 or 3 of them together. All right, let's see. If a tree casts a 24-foot shadow at the same time that the yardstick casts a 2-inch shadow, find the height of the tree. Well, this is just basic submarine periscope readings, 101. However, the way that we did it in Subfleet was we used sine angles and sine identities in order to do the math quickly. Now we just basically have to set up a proportion, and yeah, we're just setting up a proportion. That'll be it. So going large to small, 24 is to 2, as x is to 3. So 2x equals 3 times 24. Which is 72. So x equals 36. So it's obviously not drawn to scale because 2 feet is much larger than 3 feet here, but again, we're not going for pure art here. So it's X is 36 feet. We're moving on. All right, let's see. A 6-foot tall tent standing next to a cardboard box casts a 9-foot shadow. If a cardboard box casts a shadow that is 6 feet long, how tall is it? So, all right, we'll do tent box. And so if 6-foot tall tent, 9-foot shadow, so we'll do 9 is to 6. Yeah, 9-foot shadow. As 6 is to x, so 9x equals 36, x equals 4. So the cardboard box is 4 feet tall. And scrolling back up here, this is 36 feet. Okay. So I mean, just kind of like in algebra class, we're doing a unit for exponential modeling, and the trick with that one is being able to doing exponential modeling, and the trick with that one is being able to read word problems. The math itself isn't very difficult, so I guess we're kind of that's the level that we're at here for similarity problems. Bodes well for the assessment anyway. So let's see, a telephone booth that is 8 foot tall casts a shadow that is 4 feet long. Height of a lawn ornament that casts a 2 feet shadow. All right, so booth to gnome. So 8 feet tall, the shadow is 4 feet long, so 4 is to 2, as 8 is to x. So 4x equals 16, x equals 4 feet tall. Oh, no, that's not too bad. A decent height on a gnome. Anyway, that is the that's what we're doing. We have the Triangle Midsegment property. Again, I would encourage you, if you're allowed to have notes for this, to just basically draw diagrams illustrating proportionalities and everything. Other than that, we have the second assessment next, and best of luck with that.